To start our discussion, we'll first talk about the i500 series frequency inverters available from LENZE. These are the newest frequency inverters in the LENZE portfolio. You'll see starting on the left side of the screen here, these are our centralized drives or cabinet drives, really designed and optimized for mounting inside the control cabinets. They are IP20 housed, and a unique feature is that they do offer side-by-side zero clearance mounting. And so really zero space between the drives as they're mounted in the cabinet. And you can maintain the full 45 degrees C ambient rating with that zero clearance mounting. So really able to optimize the panel space using the centralized or cabinet drives. On the right side of the screen, you'll see our latest offering in the frequency inverter portfolio. These are our i500 ProTech drives. These are really optimized for field mounting on the machine, mounting near the motor, near the machine. They're available in two different housing options. First is the IP66 or NEMA 4X housing, which is outdoor rated. There's also an IP31 or NEMA 1 housing. With the IP66 NEMA 4X housing, there is also an optional service disconnect switch available. That switch is really intended for servicing the motor and the equipment directly driven by the motor that's connected to the frequency inverter. Although these two products may look quite a bit different, as you can see, they are all built on the same hardware architecture and firmware architecture. So the commissioning tools for both these products are the same tools. The operating system is the same. If you are familiar with one series, then you're familiar with the other. If you're familiar with the cabinet drive, then you'll also be familiar with the ProTech drive. For those of you who really haven't seen these products before, we have a brief video that I'm going to show here in a minute, and then we'll be back to start the discussion of group installation with the i500 inverters. The i500 series drives are ideal for industrial machinery and packaging machinery, and they can really bring a value to the machine design process. One way they really can bring a value is with their group installation compatibility. What is group installation? NFPA defines group installation as two or more motors or one or more motors and other loads and their control equipment shall be permitted to be connected to a single branch circuit under the conditions specified. And what they're really saying there is you're allowed to have two or more motors and controllers, in this case frequency inverters, protected by a single branch circuit protective device. So instead of individual branch circuit protectors in front of each frequency inverter, you just have a single branch circuit protector, so you can minimize the number of components and things in the machine. NFPA 70, the National Electric Code, and NFPA 79, the Electrical Standard for Industrial Machinery, both have guidelines and requirements for applying group installation techniques. Both the NFPA 70 and the NFPA 79 are recognized and actually referenced by the ANSI PMMI standard, the safety requirements for packaging and processing machinery. Applying the guidelines in the standards to accomplish group installation permit the reduction of the number of branch circuit protectors that may be required on the machine. All this leads to some significant benefits in the machine design. As the market continues to demand machines that are more compact and machines that take up less floor space, optimizing the size of the machine, the size of the control panel, the number of wires, the number of connection points are all beneficial to the machine design. These things aid in the cost reduction of the machine, of course, but they also aid in the reliability. If you can eliminate some wires and you can eliminate some connection points, that's towards the more reliability of the machine. So there are cost and size benefits, but there's also some reliability benefits as well. Here's an example of a typical group installation using the i500 series ProTech frequency inverters. A few things I want to highlight on this slide. Starting from the left, you'll see, of course, an AC power source that is, in this example, connected to a 30 amp UL489 marked molded case circuit breaker. That's the branch circuit protective device for the group. The thick black horizontal line represents the branch circuit conductors. The thinner vertical lines that go to each individual frequency inverter, those represent the tap conductors. And then, of course, coming out of each frequency inverter to the motor are motor conductors. The NFPA 70 and NFPA 79 standards both have requirements for sizing the branch circuit protector and these conductors. We'll see that come back in another slide here in just a minute. A few other noteworthy requirements laid out in the NFPA 70 and NFPA 79. They state that the frequency inverters must be marked suitable for group installation. The i500 cabinet drive and ProTech drives both carry that suitable for group installation marking. Of course, in our documentation, we also must list the maximum branch circuit protective rating. We must list the rated mains current and the rated motor current. All our documentation completely complies with the requirements of the NFPA 70 and the NFPA 79. Here's an example of an NFPA 79 compliant group installation system. You can see on the slide here, throughout the slide, I've referenced the relevant NFPA 79 tables and sections where they apply. Starting at the top, in this table, we have some data regarding the frequency inverters that we're using in this group. In this example, there's 4 i500 series ProTech inverters. They're all 480 volt. 4 different power sizes, 0.75 kilowatt, 1.5 kilowatt, 2.2 kilowatt, and 4 kilowatt. And we list the mains current, the motor current, and the maximum branch circuit protective device allowable for use with these frequency inverters. To start the sizing, we'll look at the tap conductors first. These are the conductors that connect from the branch conductor to the frequency inverter itself. These are connected directly to the input terminals of the frequency inverter. Those are sized based on NFPA 79 table 12.5.1 using the mains current ratings of the inverters. Next, we'll have to size the branch circuit conductor. That's the larger conductor that feeds all 4 frequency inverters. To size those conductors, we have to do a calculation. The calculation is defined in NFPA 79 12.5.4. What we have to do is take the largest load in the branch, so in this case the 4 kilowatt inverter, mains current of 10.5 amps. We multiply that current by 125%, and then we add the remaining mains currents. And in this example, we get a total of 26.9 amps. That is the minimum required ampacity. We must use that value to size the conductor. We go back to our NFPA table 12.5.1 for 26.9 amps. The result is that we can use a 10 gauge wire. Next, we'll look at the motor conductors. Those are also based on the motor currents in this table using NFPA 79 table 12.5.1. There we result with 14 gauge. So now that we've got the branch circuit conductor, the tap conductors and the motor conductor sized, we can look at the branch circuit protective device. And here we have two requirements to meet. One is the maximum rating specified in table 7.2.10.4. That table references for the smallest conductor in this circuit, which is a 14 gauge, we can use nothing bigger than a 60 amp branch circuit protective device. There's also a second requirement here that says the maximum branch circuit protective device allowed cannot exceed the rating of the smallest device in the circuit. So that's really what's driving the sizing here. In this example, the smallest device in the circuit is the 0.75 kilowatt frequency inverter. That has a maximum branch circuit protective device of 30 amps. So that's the result, is we can use a 30 amp branch circuit protective device for this group. I'll show a little bit more detail of this example in the next slide, but this is the methodology for determining the conductor sizing and the branch circuit protective device sizing. So here's a little bit more detail about that example and the methodology for calculation. You can see here we have our 30 amp UL489 listed molded case circuit breaker, our branch circuit conductors 10 gauge, our tap conductors 14 gauge, our motor conductors also 14 gauge. This is all based on the calculations we did a moment ago. The one distinction I want to make here is the length limitation of the tap conductors. In this example, they're limited to 25 feet. This has to do with the relationship between the wire gauge, the wire size of the tap conductors versus the branch conductors. If we chose to, we could use also 10 gauge wire for the taps. And if we did that, there would not be any restriction on the length. In this example, we calculated that we could use 14 gauge, and we did use 14 gauge. That 14 gauge, of course, is a little bit smaller than the branch circuit conductor, which is 10 gauge. And that drives a limitation, in this case, of 25 feet maximum. These taps can't be any more than 25 feet long. Again, if you wanted to match the same gauge as the branch conductor, that restriction goes away. But there are length limitations in both the NFPA 70 and the NFPA 79 with regards to tap conductor length, and those restrictions are based on the relationship of the wire size between the tap conductor and the branch conductor. We chose to talk about this topic today due to increased interest from our existing customers and new customers. Our application engineers and sales engineers are often fielding questions about group installation compliance. So I hope we've been able to shed some light on the subject today and demonstrate a path to compliance with the i500 series. And we hope you can take advantage of that in the design of your next machine. We've taken actions and measures in the specification stage, the design stage, and the UL validation stage of developing the i500 with group installations in mind. So we hope you can leverage that. And please reach out to us with any questions on this subject. Thank you.